Everything is up and running, and we will be doing a class diagram for the implementation and sequence diagram that we have already done. So we could take a look at how the structure of the classes are. And I'm using Visual Paradigm for UML Community Edition. So application for this. I like the class diagrams, but I don't like the sequence diagrams in it. But you can't get everything often in these types of applications. But as you probably know, we have three packages: model, view, and controller. And inside of these packages we have a few classes. And in the view I think it's quite easy because we only have the console. And in the controller it is also easy because we have the player. And in the model we have card. We have deck. We have dealer. And we have player. So, something like this. And now we need to kind of like add the correct relationships between these types. And we could just take a look at the code, and maybe let's start with card. Has color and value as enumerations inside of it. I won't add those. I think we did so in the beginning. So, well, I won't add those, but those are definitely there, and if you're really detailed, you should add them. Otherwise, we have just a Boolean, so no special associations. Well, basically, the card just uses colors and values and stuff like that to manage itself. So no arrows going out from card, at least. Next step is the deck, and here we have an attribute, a linked list that holds the cards, so it contains a lot of cards. And this is definitely something that we should add to the class diagram. And since it's an attribute in the class, it is modeled as an association. So I think we can get it like this: association, deck and card, and in this little program we need to do it like this. And multiplicity, let's add the star, and role name. It was just something like that, wasn't it? Yeah. So instead of saying linked list, template class, card, stuff like that, we're just saying that, well, this association can hold many cards. How it is implemented is kind of like uninteresting for now. So let's move on. The deck, well, it uses its linked list. It creates a lot of cards. It works with cards. Nothing more, it seems. So the deck is done. Maybe take a look at the player next. We have the hand. Same concept as in the deck, a linked list of cards to hold a number of cards that we call hand. So this should definitely be added, and it should of course be added as a association. do it in the same way as we did before. All right, let's take a look at the code again. Player works with the hand, card, hand, card. So does not seem to have anything special going on. If we would have added the count, the value in the card, then we could have added a dependency to this contained type enumeration. But as you already have a dependency to the card, I don't think it's that necessary. But if we really, really wanted to be specific about this dependency, it could be an idea to add it. So let's move on to dealer. Dealer, we have the hand again, and we have the deck. So associations for these. Deck. If you would like to be really specific, you could also say 1, but I think it will just add uninteresting information. So something like that, and we have also to the card. So something like this for now. However, here we have something interesting. We have an argument of type player that is used here in start game. So this should definitely be added to the class diagram also. And since it is not an association, but rather an attribute, an argument to an operation, we have a dependency. So I think the model looks something like this. Any questions? Good. Let's move on to maybe the view. I think this one is a little bit easier. Basically, we have an integer here, not that interesting to show. We have some instructions and strings, not interesting to show. However, we do have this. We use card here in the view. Card, card, card. This is about it for the view, actually, I think. So, once again, we have an argument to an operation that has a type that is interesting to show. So we have a dependency to the card class from the view. And lastly, controller. Here we have a bunch of stuffs. Dealer, view, player. So that's about it. So let's add them, and they are, of course, also dependencies. So basically, I think our class diagram would look like this. And we could, of course, check for architectural integrity and see if we have any arrows going from model to the controller or to the view. And we don't have any arrows pointing from model to view, so that seems a-okay. We have also managed to keep the view independent of the controller, The view does not know anything about the controller. And the controller, well, maybe that's the class that we need to kind of like sacrifice in order to get this design, because it's kind of like the middleman here and coordinates the user interface and actions to be performed inside the model. So controllers typically are quite coupled and messy, and that's maybe the price that we need to pay, because somewhere someone needs to know about a lot of stuff. But both our model is quite good, and the view I think is quite good, because thinking about it, you can actually reuse this view right now. It would be no problem to have another type of card game and just display the cards and scores using some other type of rules, because the view is not dependent on that this game is blackjack and stuff like that. Maybe a little bit in the menus and something like that, but not too much. So that's kind of interesting. All right. Any questions? All is as it should be. However, maybe you noticed me doing something once more when we did this, have done this implementation, and noticed something bad in the code. Any idea of what that could be? I did it today. I did it yesterday. I copy-pasted. We have this get score in player. We have the exact same implementation in dealer of get score. We have the exact same implementation here, clear hand, get hand. We have this linked list of cards that represents the hand. That is the same in player also. So we have seen some code duplication here, and also maybe looking at the class diagram, we can see that, well, this relationship here, M hand, from both dealer and, is this one? Is the same. So what should we do? Indeed, maybe the dealer is a player. And exactly, we have a class player and dealer inherits from that class. And maybe that's even something that we could have figured out already in the domain model, actually. That the dealer is a kind of player. He also, or she also plays the game, actually. This is maybe not the case in all types of card games, because in, for example, poker, you have players and then you have a separate dealer. However, in blackjack and maybe other card games also, you kind of like play against the dealer and not the other players. So indeed, both the code and actually the domain points towards this inheritance, that the dealer is just a special kind of player. So I definitely think that this is a good opportunity to add this instead. And then we can actually remove this, delete. Because it will be inherited instead. So, good. Let's do it in the code also, and we will see what happens. So, dealer and we can remove this and this and this and this, and I think this one also. And this. So basically, everything works as before. We could just throw away a bunch of code, reuse code from the player using inheritance instead, and also conceptually, everything seems to be fine, actually. So I think this was a really good refactoring that we did that affected the design. And as I said, if we would have been smart or clever or really thought about it, maybe we could have realized this already in the domain model and not needed to add this flaw in our design and our implementation by thinking a little bit ahead instead. So, but it's not always easy to do. So then you get maybe this flaw visible when you look at the code instead, or when you look at the class diagram instead. So we can always try to look at these different types of representations of the system to find opportunities to make improvements. And if you can do it earlier, it is better, of course, because then you don't need to maybe add flawed stuff that later needs to be removed. But then again, thinking a lot ahead is often hard. So it's good to find a balance. But definitely you should inspect your code, and maybe when you have coded something, well, okay, let's make a design for this part of the code that we have just worked on. Have we added something that is strange or unnecessary? Could we move this functionality to some other part instead? Will we get a better design then? So refactoring is not something that should be considered a failure, but rather something that is a part of the daily work of a developer. All right. We have one thing that I maybe would like to actually add here. And we have this association from player to card that says, well, the player works with cards, and a player works with cards and puts cards in its hand. But if we look at the dealer, it kind of like uses cards in another type of context also. It uses cards from the deck, and it kind of like uses functions on the card. It just does not store it and have it in the sense of having stuff in its hand. And maybe this is not that clearly visible in this diagram. It seems like dealer and the card is kind of like quite a bit away from each other. But in reality, they're quite dependent, or the dealer is quite dependent on actually dealing with cards. So it could be an idea to actually add this dependency also. Strictly speaking, it is maybe not needed, but it could be a good good hint for someone that maybe thinks that, oh, okay, if I just remove kind of like the deck and the player relationships from the dealer, then it is free from the card also. But that's not actually the case. And one could also argue that this relationship between the dependency between dealer and player could be removed as we inherit from player. So we already have quite a strong dependency there. On the other side, we use another object, another player object, and we use this object quite intimately also in the dealer. So it could be an idea to keep this relationship here, although it is strictly maybe not needed because we have the inheritance already. So even when doing these kinds of diagrams quite mechanically, maybe you need to think a little bit about what you actually want to show. And we could also have these types of dependencies that are more or less hidden inside the code. For example, in the calculate score part of things, this array is dependent on the number of enum values inside this value enumeration inside card. And this could also be something that it's not clearly visible in the code, but we could add it as a special dependency in the design if we would like to really stress that dependency. So mechanically doing diagrams is a good start, but often you need to kind of like think a little bit about what you would like to show, and the hidden dependencies are particularly bad in this respect, that they do not show clearly in the code, and then maybe we should add them to a design instead so that we have some form of representation for it. I think we maybe have a question here in the chat coming up. Okay, I will just continue while we are typing. This should, of course, also be updated a little bit. We have score calculation here, so I will do that later. This is an example from the third workshop, so we won't take a look at that anymore. Yeah, we have, all right. Can we handle the low-level input also in the controller, i.e. giving back an integer and decide in the controller for each int instead of calling always a new function once to play, once to manage in the view? It kind of like depends. The modern use of a model view controller is to move low-level input into the view. Controllers has the disadvantage, so to speak, that they often become quite coupled to other classes, both in the model and in the view. And in this case, this would mean that we add kind of like further bloating into the controllers by adding this low-level input also. So I think you should strive to handle low-level input inside the view and not in the controller, especially if you have this kind of like scenario controllers that we have been doing right now. In the early days of model view controller, it was kind of like one value in the model was coupled to one very, very small controller that handled input from maybe the mouse, and we had one very small view or several small views that visualized this single value. So back in the days, it was more of a micro pattern or something like that. Nowadays, it's more of an architectural pattern. Depending on how you solve this system event handling in the controller, it does not need to be like this. I think last year I returned an enumeration of events instead, and we had a switch clause here, so you can take a look at that. You could also use the observer pattern to plug a listener into the view, and then you will get calls for each and every method. So, well, you could do it in this particular detection of the system events in several different ways. Yeah, the decision of the controller needs some way to detect that an event has happened, and you can do that in several different ways, as I said, and with an enumeration or something like that, you would have a switch statement, or you could plug in something in the view that will get callbacks. But essentially, the idea is that in some way the controller needs to know that, well, okay, the user wants to do something, and then I need to collect the information that is needed based on this event that has happened. And typically, well, I ask for the member's name, and I ask for the member's social security number or whatnot, or I ask for, okay, can I get the member that the user wants to add? So I get the whole object instead, and then I take this object and I send it into the model so that the model can do whatever it would like to do with it. So the dealer or the controller is often the kind of like the middleman here. But the exact solution is maybe you could do that in different kinds of ways, the exact implementation, depending on what you would like to do. And you could have several controllers in a more complex environment, complex requirements, and then this small one. You can have controllers that form some kind of hierarchy. You have a controller for the main menu, and when you do something in the main menu, it's kind of like nothing really happens, but you just go further down, and when you have pressed add member in the main menu, you go to the user interface of adding a member, and the system event is actually that a member is added. So finding a good balance between view and controller, it's not that easy. So strive to find to have roughly at least the same amount of code in controller and user interface and view. All right, but it's not that easy. It's not something that is easy to achieve always. So, but anyway, we have fixed the deal cards requirement. We have made a class diagram. We have made some refactoring. We have improved the design and the code and implementation. And now it's time to take a look at the rest of the patterns in the grasp sense, at least. So one new pattern here is low coupling, and The problem is about what design to favor if we want low change impact and reuse. And this is something that we kind of like always would like to have. So low change impact is about if we make a change, it should not spread all over the system. It should be as contained as possible. And we should at least know what parts of the system are affected by a change. And reuse is, of course, we would like to use parts of our application and implementation and design also, maybe in other projects. And if we have several ways of designing, and as you saw maybe in this add score stuff that we did, we can design however we want. And different designs have different drawbacks and advantages. So thinking about low coupling is to select the alternative that offers the lowest amount of dependencies. And that means the lowest amount of arrows going in or out from a type. So you can simply just count the number of arrows in your design. Then you can also maybe look at the types of arrows also and see that, well, dealer and player, well, they are quite strongly connected. It is not so easy to reuse the dealer without getting the player and reusing that one also, or trying to remove it. And when we have the dealer, oh, okay, we need the deck also, and we need the cards also. So if we would like to reuse the dealer, well, more or less we need to take this whole model package as it is now. So counting outward going arrows means that, well, dealer is, well, maybe not that of a large, good reuse candidate in this project. On the other side, if we look at card, it has no arrows, no relationships going out. So it would be quite easy to actually reuse this class. We could take it as it is, since it has no dependencies going out here. So if we're looking for reuse, if that is important, look at outbound dependencies. And on the other side, change impact. If we change something in the card class, there is a high probability that many other classes will be impacted by this change, since we have a lot of arrows going from more or less, I think, everything but the controller to card. So this is indeed something, changing something here could have serious effects in many, many parts of our system. And this is something that you can, if you have a diagram like this and you have a change request, oh, we need to do the add this feature or change this stuff, and you can see that, holy crap, that one will not be that easy to do in a good way. And this could of course influence if you should do that change at all, or how long time it will take to do it. So these relationships, these arrows going in and out can be used for different purposes. And we also have more advanced metrics like fan in and fan out if you are really into metrics and stuff like that. And it is also so, in many cases you can't kind of like just have the cookie and eat it. So you need to kind of like decide, is this class something that we would like to fight to have reusable, or is it something that, well, it doesn't matter really. So pick your battles. You can't have everything reusable and everything with low change impact. Typically in our case, well, the card class is quite reusable. I would be hesitant to add some relationship from card to something else, actually. I would not like that. Possibly also deck is quite reusable. I don't think dealer and player is that reusable right now, so I would not fight to have them reusable. The view is interesting, I think, because I would be hesitant right now to add relationships to player or dealer in the view. We could do it instead of sending the hands in here and having different functions in the view for player hand and dealer hand. We could just send the player object and the dealer object inside and add dependencies, and the view could get the hand, but that would tie the view more tightly to this model of the blackjack game with dealer and player. So I would be hesitant to do that. And as you probably have noticed, well, the controller, it's something that we will need to kind of like sacrifice to keep things separate as possible. So, low coupling. And finally, watch out for hidden dependencies. Sometimes you have these dependencies that are there, but they are not really visible in the code. And you think that you can reuse this, or you think that the changing here won't impact that other part because there is no arrow in the diagram, but in reality, things blow up. High cohesion, another evaluative pattern that strives to make classes easy to understand. They are focused, and by this they become maintainable. And we should assign responsibility so that the class is responsible for one thing. For example, in our score dilemma, we thought about adding the score to the card maybe, but this would mean that, well, the card would become responsible for not just handling its value and color and if it's hidden, but also for scores. So we are adding more responsibilities to this class, and, well, it won't be as focused and maintainable and easy to understand suddenly. And basically, you can measure cohesion by looking at a group of related functions that work on the same attribute. So if you have parts of a class that work on one set of attributes and another part that works on another set of attributes, well, maybe this class should be split into two instead. Maybe we had this in our dealer class when we had the code duplication between the player and the dealer. We could also look at the cohesion of the dealer and see that, well, we have this set of functions that work on the deck attribute, and we have another set of functions that work solely on the hand attribute. And this kind of like made the dealer lower in cohesion, and it was something that we could also see in the code and understand that, well, we should split this and we should reuse this code instead. Often this also supports low coupling. If you remember back, we did this in this little circle class way back, and we had a circle class that was responsible for the math operations of a circle. It had a radius. But then we also added this, it should be a visible circle that has a user interface, so we need to add color and position and a whole lot of attributes. And then we had a rendering function that worked kind of like only using these new attributes, and the math functions only use the radius. And this rendering function also was coupled to some kind of representation of the screen. So by making a class lower in cohesion, you often need to add couplings to it also to manage these other parts. Next idea is to avoid selection based on type. So if you have some kind of behavior that should vary based on a type of based on the type of a class, you should use polymorphism. So you should not write, if this stuff is of this type, then do this. If this stuff is of the other type, then do that. So try to use polymorphism instead. So you should assign the responsibility to some kind of operation that you can be overridden in different types of classes. So avoid these kind of like extra states or type information and reflection if you can. Streaming is cut off. Okay. Okay, can you other guys see? Okay for me. Okay, I think it's something then locally. All right, good. You never know with Connect, so. That was polymorphism, and we have this pure fabrication pattern also, and it's basically says that you are free to invent stuff. You don't need to abide by the domain model or reality if the domain or reality offers no good solution. For example, in respect to coupling, cohesion, reuse, change, etc. So then you're free to invent stuff, and that's good, because many good designs rely on and many good patterns rely on stuff that actually do not exist in reality. And in our example, well, both the controller and the view, those are software concepts and has nothing to do with reality at all. So this is software. We can do what we want to achieve our requirements and achieve our goals. All right, is it okay to give a validation type for the input method so it checks either for strings, integer, etc., etc.? Sure. I'm thinking you need to do this inside the somewhere inside the view. You need to kind of like check input, and that is a little bit of a different case than using type information on your own domain model types. So input that comes from the user should, in most cases, of course, be validated in some form, and you need maybe to know what type of input it is, if it's strings or integers or whatnot. And also this cannot, maybe polymorphism cannot always be achieved. It is okay if we have association from view to model. Indeed it is. The pattern says nothing about relationships going from view or controller into model. There are different variations that says that you can't, but you don't need to use those variations, of course. If you want a completely reusable view, then you should not add them. But that's often quite hard. So next pattern, how can direct coupling between classes be avoided? So we can assign responsibility to an intermediate class or to mediate between others. In our case, the controller is indeed such a class. Instead of coupling the view to the player and dealer, the middleman, the controller, takes the hand from the dealer and the hand from the player and gives it to the view instead. So we can avoid direct coupling between the view and the dealer and player in our case. And lastly, how can we design so that variation or change in parts of the system do not impact other parts? Yeah, and this is something that we have been discussing a little bit, at least. There are always things that can change and vary in a system, depending on, well, the user thought he wanted something, but actually when he sees the system, he wants something else, or want to change some detail. Oh, I would like to be able to add this also now. Or we could consider, for example, the rules in our game. There are a lot of variations of rules in blackjack, so maybe we should kind of like try to design this in some way so that we can change the rules easily. And this is what you kind of like do in protected variations, and the idea is to try to find the parts that can vary and encapsulate these points in an interface. And interface in this sense is the kind of like the broadest type of interface you can imagine, not just the interface kind of construction in Java or C# or so, but rather an idea of encapsulation and not and showing as little as possible to the outside world, so that you can more easily change stuff behind the scenes. So this is not something you can do for every type of change. Some changes are hard, others are easier, and depending on your goals, you need to kind of like pick what types of changes are likely and what would we like to be able to change easily in our system. Typically, we did this by using the model view controller pattern. The idea of this is to easily vary the user interface, have different types of visualization for our application. So this is kind of like a change that is built into the architecture of our system. So it should be easy to, for example, create another type of a view. So we did it for the dice game, we made an interface or an abstract base class or whatnot, and we had this encapsulated the view functionality in this interface, and we could more easily add new types of user interfaces, new types of views, by having this variation or instability encapsulated by inside the view component or view package. So I think that was it for the grasp patterns. In Workshop 2, anyone can add a member or both to a member. We do not need any login or something like that. All right, the grasp. General software relationships, software assignment patterns or something like that. Information expert is always an idea you can go back to if you have trouble deciding where to put functionality, where to put data. Try to find out what type of information is needed to perform the requirement, and put this where in the class that has this stuff already accessible. And it could be the case that, well, the information needed is spread out in several different places. And then maybe you need to invent something that can hold information from all these places and add the relationship, the responsibility to this part. Information expert, very, very important to grasp. And we have creator and controller. Those we have used those. Then we have these evaluative patterns, low coupling, high cohesion. And then we have some more or less goal-driven patterns that you can kind of like, okay, I would like to achieve variation, or it should be easy to change this, and stuff like that for the next part. Do we need to do 3 different diagrams for the grades, or can we just extend the one? You should have 3 different diagrams that are at least clearly labeled, but in part they will, of course, be very much the same. All right. Any questions regarding the patterns? I think that I will implement the rest of the requirements for hit and stand using the design that we have right now. Basically, it will be detecting the system event in the controller and then telling the dealer to, well, the player wants to get another card, or the player wants to stand, so now you go. And finding out who has actually won the game towards the end. And for next week, I think we will start with the gang of 4 patterns that are maybe more interesting and more, well, maybe a little bit more specific and advanced. So any other questions? All right, don't hesitate to use Slack or something like that. So good. See you next week then. And don't forget to send in your workshop number 2 for peer reviewing. I think it's the 7th. Yes, 7th at noon, and I will compile the peer review list as soon as possible after that. So you should be able to start with the peer reviewing also. All right, bye for now.